Welcome to The Explainer. Today we are breaking down a massive shift in how AI value is captured, and it's all being triggered by a critical geopolitical loophole. We're going to be looking closely at model distillation, open weights, and why durable AI profits might actually be migrating entirely away from the models themselves. It's a truly fascinating shift in the economics of intelligence, and it is absolutely going to change how we evaluate everything from semiconductor demand to software moats.
Okay, let's dive right into this by posing a core dilemma. Think about it. America has a lot of tools at its disposal when it comes to physical hardware, right? We can inspect a shipment of advanced GPUs. We can restrict a fabrication tool at the border. We could even track the energy usage of a massive data center. But what happens when the product you're trying to control isn't a physical chip? You're faced with the near impossibility of stopping invisible knowledge. Because how do you stop the outputs generated by an AI model from seamlessly crossing those exact same borders?
To understand exactly how this invisible transfer works, we need to look at an investigation from Reuters back in July 2026. The report revealed a striking dynamic. Chinese military and security researchers have literally been using the outputs from advanced US models, including systems from OpenAI and Anthropic, to train their own smaller, domestic models for highly specialized tasks. Reuters reviewed over 80 Chinese papers and patents detailing this exact practice. Now, this doesn't mean chip export controls have failed, but it exposes a fascinating new reality where intelligence can be siphoned directly through an API.
Here is our roadmap for this explainer, moving from this geopolitical trigger into the underlying economic shift. We're covering 1. The invisible AI leak, 2. The economics of model distillation, 3. The NVIDIA compute equation, 4. Who owns the customer, 5. The sovereignty premium, and 6. The 5 layers of AI moats.
Section 1. The invisible AI leak, transferring capabilities. We're witnessing the emergence of a completely second transfer channel in the tech race. In the primary channel, the Frontier Lab pays billions of dollars in compute, talent, and energy to create a baseline intelligence. But in this secondary channel, another organization captures a significant slice of that intelligence through reasoning traces, synthetic data, and output examples. The creator bears the massive upfront cost, while the observer reaps a highly specific benefit.
Section 2. Economics of model distillation, the R&D rent leakage. It's absolutely crucial that we stop viewing model distillation as just some neat technical curiosity for developers. It is, in fact, a massive economic arbitrage. It creates what we can call an R&D rent leakage problem. You have Frontier Labs investing unprecedented capital to create a capability, only to have competitors partially reproduce the most valuable, use case-specific parts of that capability at an absolute fraction of the original cost.
Contrast these two players, the teacher model versus the student model. The expensive Frontier teacher model is the one absorbing all the friction. It takes on the Frontier research, the massive training runs, the safety guardrails, and literally all the failed experiments. The student model, on the other hand, is cheap. It simply learns selected behaviors by studying the teacher's correct outputs. No, the student isn't universally as smart as the teacher, but it is incredibly cheap to deploy locally and perfectly capable of handling the narrow task that actually generates revenue.
Because of this dynamic, we actually have to define a new metric for the AI era, the half-life of model advantage. If a company releases a groundbreaking model today, sure, they might be meaningfully ahead on the benchmarks, but because competitors can immediately study its outputs, imitate its product features, and use it to improve open-source models, that economic lead decays incredibly fast. A model's lead decays much faster than physical infrastructure, like a cloud region or a semiconductor architecture, simply because digital capabilities spread at the speed of light.
This really exposes the vulnerable position of relying purely on intelligence as a business defense. A weak moat in today's landscape is just saying, hey, our model is smarter today. That intelligence is perishable. It diffuses. A strong moat is being able to say your employees, your proprietary data, your compliance policies, and your measurable business outcomes are entirely built around our platform. The durable switching costs of deep workflow integration will outlast any temporary lead on a benchmark test every single time. Section 3. The NVIDIA compute equation, rethinking demand. You might look at this trend of smaller, highly efficient models and think, well, that sounds terrible for hardware companies, right? If models take less compute, doesn't NVIDIA lose? Paradoxically, this trend toward distillation might actually be surprisingly bullish for the compute sector.
To understand why, we have to apply the Jevons paradox to AI. In economics, the Jevons paradox happens when technological progress increases the efficiency of how a resource is used,
but the fall in cost actually drives total consumption of that resource way up. When AI models become cheaper, smaller, and vastly more efficient, organizations don't just pocket the savings and run the exact same number of queries. No, the cheaper models unlock thousands of brand new, specialized tasks that were previously too expensive to automate, which explodes overall demand.
So here's the math. Crucially, the compute required per individual task is decreasing rapidly as models get distilled, but the total number of tasks performed is increasing exponentially. Instead of one expensive, generalized AI assistant, a company might deploy 1,000 specialized agents handling code review, customer support, fraud checks, and industrial inspection 24/7. The aggregate demand across all of these agent actions, post-training and synthetic data generation, goes up, hugely benefiting the underlying infrastructure providers. Section 4. Who owns the customer? The open versus closed war. We hear endless philosophical debates about open source AI versus closed source AI. But at its core, this isn't about philosophy. It is a brutal economic war where every mega-cap tech company is defending its distinct economic model, based entirely on whether they own the raw intelligence or if they own the customer distribution.
We are really looking at 4 distinct business models here. First, you have Meta. They want to commoditize models by making them open and free, because their profit engine is distribution and advertising. Cheaper intelligence just boosts their existing network. Second, OpenAI and Anthropic. They absolutely must secure enterprise workflow lock-in to recoup their astronomical R&D costs. Third, the hyperscalers. Think Microsoft, Google, and Amazon. They win by monetizing the underlying cloud infrastructure, no matter whose model you use. And finally, the control plane layer. These companies connect interchangeable models to proprietary data, making the operational context the real product. The durable moat is clearly shifting away from model ownership directly to customer ownership.
Section 5. The sovereignty premium. Security at the edge. Distillation heavily changes the security equation for major organizations. We really have to focus on why certain sectors are fundamentally demanding local deployment of models, rather than relying on a continuous, live connection to a massive API hosted somewhere else.
The reality is that defense agencies, financial institutions, healthcare providers, and critical infrastructure operators simply cannot risk sending highly sensitive data to an external API. Because of this, they will pay what we call a sovereignty premium. They'll gladly pay extra for the right to keep their inference entirely local, inside a private network with full auditability. This creates a massively lucrative market for open-weight and distilled systems that can be downloaded and secured on the edge, completely independent of any foreign or third-party server. Section 6. 5 layers of AI moats, where value accumulates. We've talked about where value leaks and why intelligence diffuses. Now, we're going to introduce the central investor framework for evaluating where durable, long-term profits will actually sit in the AI ecosystem over the next decade.
Watch how this builds sequentially from top to bottom. At the top, layer 1 is distribution. If you own the customer interface, you can just swap in better models as they emerge. Layer 2 is proprietary data. Models are only as good as the unique operational outcomes they learn from. Layer 3 is the compute ecosystem, the hardware, networking, and software platforms that run the whole shell. Layer 4 is the control plane, which handles irreplaceable security, identity, and policy systems. And sitting at the very bottom, Layer 5, is frontier research. It's vital, sure, but surprisingly, it is the most highly perishable moat because that model lead diffuses so quickly. As you evaluate this space, you need an impartial look at both the bull and bear cases for AI investment, especially as distillation reduces the economic rent at the model layer. The bull case argues that as models become cheaper and more specialized, it unlocks enormous dormant demand. Workloads explode, and infrastructure providers and distribution networks thrive. On the flip side, the bear case warns that model prices might collapse so rapidly that enterprise switching costs stay low, and the massive capital expenditures currently being spent will vastly outpace actual profitable demand. So how do we know which scenario is actually playing out? Here are the 4 key metrics investors absolutely must track. 1. Monitor the price-performance gap of open-weight models versus closed models. 2. Track the percentage of enterprise workloads that are dynamically routed across multiple models. This is what we can single-provider lock-in. 3. Look at total inference compute across the market versus just the compute per individual task. And 4. Keep a very close eye on the gross margin direction at the model companies themselves. Bringing this all together, we have the ultimate investor scorecard. This maps exactly what must be true for each major layer to succeed in an era of model abundance. For NVIDIA and the hardware layer, total workloads must grow faster than compute per task falls. For Meta, open models must remain competitive enough to drive mass user engagement. For hyperscalers, customers must want to run a multitude of different models seamlessly on their specific cloud. For OpenAI and Anthropic, their frontier innovation must consistently outrun diffusion and secure deep workflow lock-in. And for the open-weight ecosystem, sheer deployment volume at the edge has to compensate for the lower price per task.
We have covered a tremendous amount of ground today, unpacking the economic realities of AI distillation. I want to conclude by challenging your paradigm with one final thought based on this explainer. Look closely at your strategy and ask yourself, are you still just investing in pure intelligence, hoping to find the smartest model? Or are you ready to invest in the structural, durable choke points that actually capture the value around that intelligence? Because while models might become abundant, the customer relationships, the deployment environments, and the compute platforms certainly won't. Thanks for joining me to explore this fascinating shift, and definitely keep these frameworks in mind as the landscape continues to evolve.